Okay, so the first question there, the tangent line, well, I already said the word already, but the first question there, you had y equals 9x plus 9 and y equals minus 4x squared plus 5x plus 9. And you've seen how to solve that already. What answer did you get? Yeah, just give me the x's.
Minus 1.
That's xy, yeah?
Yes.
Yeah.
X. That's X.
X and x. Okay. So this here, the line meets the quadratic twice. Okay? But it doesn't always have to meet it twice. Sometimes it could meet it once, and sometimes it could meet it no times. Okay? So this one here meets it twice. So I'm going to draw this graph here for you now and show you that. And then we'll have a look at where it meets it once, which is a special case. Yeah, I obviously said the word, some people know it. But there's a special name for when the line touches the quadratic once. And that's called tangent line. Okay, so if I look at the answers at the back, I can see that the first time that happens is 1D. In question 1, I just ask you to tell me if it's a tangent or not a tangent. Okay? So is it a tangent or not a tangent? So the first one here is not a tangent because you just told me it meets it twice. So if I just sketch it here very quickly. And what did you say the 2 points were? Minus 1 and
0.
So that's here. And then the other one?
0 and 9.
0 and 9. Okay, so the quadratic, oops, it's upside down. Quadratic's like this because it's a negative x squared. And then the tangent line, or it's not a tangent line actually, goes here. Can't quite, let me exaggerate that a bit. Make it more curved shape. There we go, that's better. So you can see here and here meets it twice. Okay. Now if we skip down to D, and I'll just get the program here to graph it, we have y equals minus 2x plus 3, and then y equals x squared minus 2x plus 3. Okay, so let me graph that. Graph it. There. Now, this one here actually only meets it once. So if I was to zoom in here, it only meets it once. And where do you think it meets it? Just looking at the graph here. It's probably like 0, 3, isn't it? So if I solve this, we're looking for an answer like 0, 3. So let's see what happens if we solve this. Solve system. 2 variables. Equation 1, equation 2. And there you go. It's at 0, 3. Okay? So my point is, for number 1, I'm asking you to tell me if it's a tangent or not. And tangent means it touches only once, which means there's only one solution. So the way we need to check is by solving. So there's nothing really new here except for vocabulary. In the exam, you might get a question where it says, solve this and this. And then for 1 mark after it, it could say something like, is this a tangent or not? You know? So question 1 is really just vocabulary. Just being clear on what a tangent is. Yeah?
So it doesn't touch, it touches twice?
It's not a tangent. You're right. Tangent is a very special case. It only touches once.
Can they possibly ask for a normal?
Oh yes, they could ask you to find the normal. And I suppose they could ask you if it is a normal. And that's something we have a separate lesson on. Yeah. Really the first one here is about vocabulary. Okay. So I'll say nothing more about the first one and look at question 2 here. Okay. So it's getting a bit trickier now. So number 2 here, I give you this curve. Whoops. Y equals, where's my pen gone? 9x squared minus 3x plus 4. Now I'll just quickly draw that one, and you should sketch it in your notebook as well. So let me get rid of all this. Y equals 9x squared minus 3x plus 4. Okay, let's draw that. There we go. That's my quadratic. And the question says, at the point x is 0, so you see here, here's the point x is 0. What's y, by the way, if x is 0? What's the y here? 4. You see why it's 4?
Yeah.
So if I just mark that in, 0, 4. What I would like to do is find the slope of the tangent line here. So before I find it, what do I think it should be? Should it be positive or negative? What do you think? If you look at 0, 4 here. Yeah, but maybe if I zoom in a little bit, I think it might be negative. But if I zoom in a bit, I would say it looks like it'll be negative, because if I draw the tangent here, it's going down. You can see that.
So the slope is negative.
Say again?
So we know the slope is negative.
We know the slope, or we expect the slope to be negative with the tangent. And actually, I think I can get the program to draw it in. Possibly. Yeah. Yeah. There we go. And in fact, I cheated a little bit here because my program actually told me the equation of the tangent at this point. So you can see exactly what it is. It should be minus 3. So how do we find it? How do we find the slope of the tangent? Well, let's go back to our question. So we know that the point is 0, 3. And we know the equation of a line is y equals mx plus c. And we know that these meet how many times? Once. Oh, sorry, I wrote 3, did I? It's 0, 4?
Yeah.
0, 4. Y equals mx plus c, and it meets once. Okay, so let's pretend we're finding where it meets. So let's solve the two equations together. What method would I use here? Well, it would have to be substitution. So I make them equal to each other, and I get 9x squared minus 3x plus 4 equals mx plus c. You just did that for me in question 1a. You're finding where it meets. What would you do next? You'd take everything to the other side. Yeah? So you're making a quadratic. Like this. Let's clean this quadratic up. Minus 3 plus mx plus 4 minus c equals 0. Okay. What would you do next here? What's next? What did you do in the first question, 1a? You solved it, didn't you? And if there were 2 answers, it's not a tangent. How many answers did you get when you did the question for me? You got 2 answers. How many answers should I get here? It should be 1. So if we think back to quadratics, there's some result I can use now from quadratics if I know there's exactly 1 answer. B squared minus 4ac equals 0. If there's only 1 answer, I know
There is minus 3 minus
that's minus 3 minus n. Thank you, Soon. I'm very sick today. Okay, b squared minus 4ac should equal 0. b squared minus 4ac should equal 0. Now that's helpful, but there's one problem here with finding the m, and what's that? The c is also unknown. So I'll park this for a moment, and I'll use it in 1 minute, but before I use this to find the m, I need to find out what the c is. How do we normally find the c? We put a point in, and do we have a point on the tangent line? We do. What is it? 0, 4. So we can put this in, where did it go? Sorry. In fact, I have it here as well. That should be true, and this should be true. Yeah. I stopped them all there. How many no-shows? Oh. Oh, okay. Hi, Stephen. If you look up the top, if we put 0, 4 in to the first equation or the second equation, it should both be true because 0, 4 is a point on the curve and on the tangent line. Also, where else could I put 0, 4? I can also put it in, you see the equation right here. Here. So, of my 3 equations I have, which would be the best one to put 0, 4 in? First, second, or third? Second or third, actually. Both will tell me what the c is. If I put it in here, what will I get for c? Yeah. I'll get c is 4. Yeah. And if I put it into this one, I also get 0, 0, 0, 0. No, not this one. I can't put it into that one. So this one's no good. There's no y there. I have to put it into this one or this one. And there's no c or m here. So it actually looks like I have no choice. I have to put it into this one. I don't have the m, but that's okay because the x is 0. So you'll end up getting 4 equals 0 plus c. So what's the c? 4. Yep.
What about if
1 second.
x is 1 and 2?
Yes, now that's a problem then when that happens. So that's one we're going to look at in a moment, okay? In this case, it worked out nice. So we can put the c as 4 in here, and we get the m. I'll get minus 3 minus m squared minus 4 times 9. And what did I say the c was? 4. Well, that's actually nice as well, because what happens here? They cancel. So I'm left with minus 3 minus m squared equals 0. So minus 3 minus m equals 0. So m equals minus 3. Well, look at that. That's what we had a moment ago. Okay. And as 2 people here at least have realized, it worked out nicely because the point had x as 0. And let's do one where that's not the case. So we'll say, I think you said Hussein, what if like x is 1? Say again? No, it's okay. Yeah, it's minus 3 here. Yeah, minus m to the right, you get minus 3 equals m. So Hussein, you said, for example, what if x is 1? Wait. What time is it now? Oh, for goodness sake, come back at 10 o'clock. Hand it in to Sylvia. Did you?
Yeah, but she said she would have it.
Because? What was the deadline time? Huh? 9 o'clock, wasn't it?
Yeah.
So come back at 10 o'clock and I might take it off you. Okay? Alright, so I'm saying, you were saying what if x is 1, for example. So that is like question 2e. So I'll do 2e now. Do you need to write that down, or can I scroll down? Do you need to write it down? You got it? Okay. Can I scroll down? Yeah? Okay. 2e. So now we have y equals minus 7x squared plus 5x plus 4. And I have the point x is 1. Okay. If x is 1, I can see what the y is. What's the y? Well, I just put x equals 1 in here and I get the y. What do I get? If you put in 1, what do you get?
2.
You get 2. This is something I found. Or you found, rather. So what I'm going to do is, I'm going to use the program to graph, again, to see what type of graph we have. So let me just draw this. Y, can you read it out to me actually? What was it? Y equals
Minus 7x squared
minus x squared
plus 7
minus 7x squared
plus 5x
plus 5x
plus 4.
plus 4. Okay. And what was the point? X is 1 and y is 2. So again, in this example, what do you think I should get as my slope here? Negative number. I should get a negative number, shouldn't I? Okay, so let's go back to the question. That's the curve, and then here's the tangent line. We know that this works for sure. I mean, there it is right there. And we know that it'll also work here. If I sub this in, I get 2 equals mx. What's x? 1. So 2 equals m plus c. So not as nice as last time. We don't have the c, but it's actually okay. I'll just put a box around this. Now we also know that if I try to solve these, I should get only one answer because they meet only once. So making these equal, I get minus 7x squared plus 5x plus 4 equals mx plus c. So I get minus 7x squared plus 5 minus mx plus 4 minus c equals 0. Okay, now if you look at this, again it's a quadratic, and we know something special here about the quadratic, that if it has only one solution, its discriminant is 0. So here we know that b squared minus 4ac should be 0. Yep. The one I just used, discriminant. Now if you look at the situation, it's not too bad. Although it's not as nice as what we had earlier. The situation is we have two equations with two unknowns. M and C, M and C. I think since we're looking for M, what I'll do is I'll get the C here. C equals 2 minus m, and I'll substitute that in here. And then this will give me a formula for m, which I can solve. So I have 5 minus m squared minus 4 times minus 7 times 4 minus c, which here will be minus 2 plus m. And that should equal 0. So we get 25 minus 10m plus m squared. Could someone type in 16 times 7, please? Plus, oh actually, well, yeah, I'll just borrow that. I forgot I can do 4 minus 2, which is 2 times 7 times 4. Yeah, so 56 plus 56, and then minus 4 by minus 7 is 28, by m is 28m, so 28m equals 0. It's not so bad, it's just a quadratic with m in it. So I have m squared plus 18m plus, let me just check that, 81 equals 0. So this is x plus 9 by x plus 9 equals 0. So, oh sorry, not x, force of habit. I meant n here, of course. m plus 9 and m plus 9. So we get m equals minus 9. And if you remember at the start, I thought that m should be negative from looking at the graph, and it is. And I can even just get the program to graph this here, which I'll do for us. Tangent minus 7x squared plus 5x plus 4x, and what was x? 1, wasn't it? So, did I get minus 9? I did, minus 9. And let's put this on the graph as well. And, oh that's because, sorry, that's because I didn't highlight all of it. Okay. There we go, in black. So in black, that's the tangent line there. Okay. Yeah. Sure, yeah. Okay. In question 3, there is one extra part to it. Number 3 is basically the same as number 2. The only difference in number 3 compared to number 2 is that I now ask for the C also. So for example, this would be like question 2. But if it was like question 3, I just ask you to continue and to find the C. So I'll just use this one here as an example. But it's really easy now, because to find the C, what do? We use a point, yeah. So we know the tangent line is like this.
In this case, the doesn't need to whatever the equation.
From my program just.
No, 2 equals m plus c. We don't even need to use parentheses.
Oh, okay.
C equals 2 minus m.
We can sub it back in and solve for m. So what was the other equation?
2 equals m plus c.
2 equals m plus c. And we know the m equals minus 9. So I get 2 equals minus 9 plus c. Oh, sorry, you're giving me the final answer. C equals 11. So the tangent line equation is y equals mx plus c. That would be the answer if I then asked you to go on and find the equation of the tangent. And if you look, that is the same thing as that. So this question is not too bad. It's a lot like 2 lessons put together. The lesson on one linear and one quadratic, and the lesson on discriminant. We're putting those 2 lessons together, and we're using those 2 lessons to find tangent lines. This is not the best way to find a tangent line, though. For those people who've seen calculus before, there are better ways, which we'll see shortly. But just as the start of the chapter, this is how we find tangent lines using what we've learned so far. Okay? Alright, so I'll give you a few of these to try. But since this isn't really too important for the exam, I'll just give you one from each. Okay? Yes, enjoy. So let's just say, yes, exactly. Yes, okay. Let's just say I from each question. 1I, 2I, and 3I. So just 3 questions, and we can do them now. You should definitely get them finished now.